Hello, I'm Kerry Cole, editor of Materials Performance Magazine, and I'm here with Elise Post and Casey Whalen. They're both with CSNRI Composites, which was recently acquired by Loctite. Thank you so much for being with me.
Thanks for having us.
All right, can you both start out just giving me a brief bit of background on yourselves and where you studied and what you've done in your career to this point?
Yeah, I'll go ahead and start. So my name's Elise Post. I have a degree in chemical engineering from The Ohio State University. After Ohio State, I went to work for Schlumberger, and I worked with electronic submersible pumps. So I worked on rigs and installed them. I did that for a few years before switching gears, still staying in oil and gas, and moving to pipelines and working for Enterprise Products Pipelines. So I worked there for about 5 years before going to what is now CSNRI. There's been a few acquisitions, so that's where I've been since about 2018 is within the composite side. It's been a good way to get my pipeline integrity background into kind of a different side of it.
And Casey?
I'm Casey Whalen. I'm the engineering manager for CSNRI. I've been doing composite repairs in the industry since 2012, so 12 and a half years or so now. Haven't jumped around too much, but I primarily do a lot of the design methodology work on the pipeline side. So looking into crack repairs and crack-like features and working on pushing our capabilities in the world of composite repairs.
Very good. Thank you. And the paper we're discussing, which was an AMP conference paper, is called The Use of Composites in Facility Integrity Programs. Can you tell me a little bit about why you decided on that topic to write a paper on?
Yes. So when working in the pipeline industry for the pipeline integrity program, for Enterprise Products, I worked in compliance and I did a lot of TVC analysis. And with composite repairs, pipelines in general are focused on a lot, but the facility integrity hasn't been as much. My husband happens to also work in the industry and did a lot of facility work. So he and I have a lot of discussions about different defects in the facility part of the pipeline. And there's been a bit more focus on facilities. And so while looking at all of our opportunities to write a paper, I thought this was a good subject because it hasn't been focused on, but there's a lot that composites can offer for the integrity of different pipeline facilities.
I see. Thank you. And Casey, is there anything you would like to add?
No, Elise was the main driver for this paper, and I'm just here to support her and help her out with any of the technical things that I myself am an expert in.
Good, I understand. Thank you. And a couple of kind of basic questions to start out. What is meant by a pipeline facility?
So the actual definition of pipeline facilities can vary. A lot of people consider it what's inside the fence line when you're going through a pipeline. So you have your main transmission part of a pipeline or gathering, and then you hit your facilities. It could be heading into like a refinery. A lot of times it could be a valve station. So it's essentially the area from where a transmission valve stops and you're hitting pipeline in what's technically called a facility. I know that's not the best way to say it, but that's kind of where it comes to. So facilities are going to have smaller pipes, a lot of times lower pressures, and just different things than the actual transmission pipeline has.
Okay. And then when you refer to composites in the paper, what is meant there?
For composites, that is a composite repair. So it could be a wet layup system with something like carbon fiber and epoxy, or fiberglass and polyurethane, or it can be a rigid coil system, which is a pre-cured system that we can also use for piping repairs.
Okay, thank you. And then can you provide some examples of specific defects in pipeline facilities that can be effectively repaired using these composites?
Yes, so facilities do have a lot of similar defects to actual pipelines, but some that are more unique to your facilities are crevice corrosions, because a lot of facility piping can be sitting on something. You also come across some different points of bending within facilities. With some of the suspended pipelines, with a longer length, you may have to deal a little more with bending loads, and that's somewhere that composites can add that extra support and help repair those. You also potentially have more soiled air interfaces, so where your pipeline is leaving the ground and going up to the atmosphere, from the ground to the air. And then another issue that sometimes you come across is internal corrosion at the bottom of an inactive line, because you do have some lines in pipeline facilities that are inactive or are only used in very certain circumstances. So there could be some internal corrosion in those spots from just where product could be sitting there.
I see. Thank you for explaining that. And how do composites repair the strength of defective pipe and transfer the stress from the pipe to the composite fabric resin mix?
Yes. So with a composite repair, it's with a defect such as external corrosion. In this case will be the easiest to explain it. You have a smaller surface area at your pipe, and your composite system will allow you to essentially increase that surface area and take the stress off that pipe. So what you're doing is, if you have an external corrosion defect, you will put a filler material in that we sometimes call a load transfer filler. On top of that, we're going to put adhesive primer and then your actual composite layup system. So your load transfer filler is doing exactly what it says. It is transferring the load from your substrate, so taking that stress off of that and transferring it up to your wet layup system. So now that load is being taken by your composite. Your adhesive primer is helping the actual wet layup system adhere to the substrate, and then your actual fabric, so your composite layup, is what's adding your strength. So that's what's taking that extra stress off of the piping in this area where it has that defect and helping repair that.
Okay. And I believe that all relates to my next question was going to be, can you explain the different components of a composite repair system? So did we just kind of go through that with the substrate and the load transfer and so forth?
Yeah, so I just do it quickly again, like the substrate is your actual piping. So whatever your material is there. So a lot of cases, most cases, the carbon steel piping. Your filler material is that load transfer filler that's transferring the stress off the pipe. Adhesive primer is essentially your adhesion between the two, and it's also acting as a extra barrier to make sure there's no water that gets under your composite. So it's a two-part epoxy system in most cases, and then your composite layup system is what's adding your strength to everything. So all of those parts are needed to make your composite system work well.
I see. Thank you. And what are the key standards and regulations that address the use of composites in pipelines and facilities?
So there's a couple different codes and standards that we deal with for this. So there are our repair standards, and what those are these standards that dictate how we do our calculations, along with different testing and engineering that we have. And those, the main one used in the US is ASME PCC2. And that has a large section on non-metallic repairs. Internationally, there is that, but also ISO 24817. And those are, helping to provide how to do calculations. From another standards point, the ones that help tell you what repair systems can be used on pipelines, those are mainly ASME B31.8 and 8S and ASME B31.4. So those two provide different guidelines based on your product within your pipe, whether it's a hazardous liquid or a gas.
How long have composite repairs been used in pipelines, and what advancements have there been in their manufacture and design and so forth?
So composites have been used for well over 30 years in the industry. The first main composite was the clock spring rigid coil, and that helped to get composites accepted into your pipeline industry. Since then, there have been a lot of advances within the technology. So we no longer just have a rigid coil. Composite companies now have different wet layup systems with different fabrics that can add different strength and deal with different defects. So there are now fiberglass, basalt, carbon fiber systems, all different kinds of resins that you can use for different temperatures and chemical concentrations when you're in a refinery kind of standpoint. Because while we do a lot of pipeline work, we also do a lot of process piping work. So another side of the oil and gas industry. The original type of composites really did a main focus on external corrosion and small dents. And in the past, even mainly 10 to 12 years, there's been a lot more testing and engineering going into composite repairs in general that have allowed or led to addressing different defects like cracks, geohazard situations, wrinkle bends, and all kinds of different defects that would never have been looked at before when the rigid coil system just started out. And that's just still continuing.
Okay, thank you for explaining that. So you talked about the difference in facilities versus longer pipelines. Are there any defects in facilities that aren't commonly seen in larger pipelines? And how do composites work to repair these unique defects?
Yeah, so probably the main ones that you will see in facilities a lot more than in your transmission pipelines are your soil to air interfaces and your crevice corrosion at different stand locations.
Mm-hmm.
Those are both mainly an external corrosion issue. So we're able to use a external corrosion calculation and find the correct composite system and amount of layers that you need for that. But when doing that calculation, you also need to take into account, since most of these are above ground, you have to take into account what UV protection will go into that system, as well as how it's going to sit on your stand or your support system. Because when you're sitting on a support system, you still have the potential of that adding wear to your composite. So when you're doing your design, you need to take that into account. With the actual transmission pipeline, you're dealing with a lot more situations of cracks and dents and external corrosion where you don't see that as much in a facility situation.
Interesting. Okay, thank you. Can you provide details about the testing performed by ADV Integrity since 2020 to demonstrate the effectiveness of carbon fiber composite systems and withstanding high bending loads?
This is where I'll probably have Casey chime in a little more because he's very good at all this the more technical situations. But essentially, go ahead, Casey, go ahead. I'll let you lead it.
So just to confirm, the question was about the testing at, where was it, ADV Integrity?
Yes, correct.
Okay, for the geohazard test?
I believe that's what it was. Casey, here, I'll send you. You can look at it. But yeah, Casey, it's the 2020, the 30-inch pipe. I believe it was part of the geohazard project that I'm sending you the paper right now so you can see it.
Yeah, absolutely. So one of the main concerns for pipeline repairs is definitely hoop stress. And most of the composites out there kind of focus on reinforcing hoop stress type defects. But there are definitely situations where we end up with axial loading, such as high bending loads, geohazard type events causing axial stresses and bending. So one thing we've been doing recently, working with ADV Integrity for the testing, is developing a different system that uses the same carbon fiber, but focuses on axial reinforcements. So the test that we discussed here, we are looking at extreme examples of corrosion or cracks in the girth welds, and then applying external bending or even loading or axial loading more recently to see what the effects are. And it's gone to show that composites can be very good at reinforcing axially as well as just in the hoop stress. So exploring these different types of defects and opportunities and partnering up and doing testing on full-scale samples is really allowing us to take composite repairs and applying it to a more general category of defects instead of focusing just on more traditional repairs like corrosion.
And what were the results of the full-scale testing conducted on samples reinforced with those carbon fiber epoxy systems and unreinforced samples?
So for many of the samples, all the samples we've tested recently in bending, the composite repair takes the strain and stress essentially away from the girth weld, and the failure point ends up being the pristine pipe body, typically outside of the composite, as that is the center point for these tests. So we're able to take high amounts of bending load, bending energy, and take it away from the girth weld, especially like a vintage girth weld that has a chance to break with lower strain percentage. So taking away all that stress away from the girth weld is allowing the failures to occur in just a buckle type failure instead of a release or a rupture in the girth weld. That really will only happen if loading is significantly high. Whereas if you have the same type of sample without a composite reinforcement, you end up getting a fairly early strain-based failure in the girth weld, which of course was going to lead to a release of the product inside the pipe. So instead of having a relatively early failure in a buckle, we're able to hold much higher loads under pressure and cause a buckle instead of a release type failure if external loading conditions get that extreme.
Okay, thank you for that answer. How can composites be used to mitigate corrosion in pipeline facilities, particularly at soil-to-air interfaces and pipe supports?
I'll go ahead and take this one. So at both these locations, since they are the external corrosion type of defect, we're able to stop your corrosion growth, but with our low transfer filler and whole system, and then take that stress off that pipe and add that strength. So your pipe is no longer weak in that spot as it was before. For both of these, we're also adding a barrier between the crevice or the support system or the soil, which will help ensure that your pipeline is no longer being degraded by those issues. So with the composite in the place where you have your pipe support, you're no longer going to have to worry about essentially, for example, the corrosive materials or the water, as an example, sitting in that crevice and causing it to eat away at your pipeline. So because your composite system is not a metal that corrodes away, you don't have to worry about that corrosion happening anymore. So you're both adding the strength back to the pipe, stopping the corrosion growth, and then ensuring that no more corrosion growth will happen at that specific location. And that is for both soil-to-air interfaces and crevice corrosion.
I see. Okay, thank you. And then can you discuss the benefits of using these composites for repairing and mitigating defects in facilities and how they compare to other repair methods in terms of cost, durability, and downtime?
So your composite repair system is a pretty quick and easy install for most cases. It can be done in a day. It cures relatively quickly, so your downtime could be a lot less than other situations. When you are in facilities, you're not have to worry as much about digging as you will with a transmission pipeline. But one thing you do still have to worry about, just an example between composites and things like steel sleeves, is welding and shutting down your actual piping. So with a composite repair, you can repair while your pipe still has product in it. But if you're doing something like welding, you're going to have to make sure in most cases, that there is no product in that pipeline, just from a safety standpoint. As far as cost-wise goes between the different repair systems, I don't have the best answer for that. It definitely varies. I don't know if Casey has any input in that situation.
Yeah, a lot of the benefits of a composite repair, Lisa mentioned, you're reducing any hot work activities. You're not needing welders to bring out any of their equipment, the materials. Composites can be installed by, you do need certified installers. With the composites, yeah, you do need certified installers to install it, but you don't need any heavy equipment or machinery, and you can get in and out of the ditch or the site relatively quick and easily with the composite repair. So the materials may not be the cost-saving point, but it's all the work that goes around doing the repair itself that really provides a great value when using composites.
Good point. So it's more about time and durability and that type of thing. Just a question in general. Who was your sort of intended audience for your paper, and what did you want people to take away from it?
Our intended audience was the pipeline companies. So with a bigger focus being put onto facilities in general in the last 5 to 10 years, and more facility integrity programs coming up at different companies, we really wanted to show these pipeline companies that there are opportunities outside of what they may consider a previously traditional repair. So show that there are alternate technologies such as composite repairs that can really be a benefit in your facility integrity program.
Got it. Thank you. And was it a well-received paper? Did you get good questions and feedback?
Casey will have to answer that, because when we actually gave the presentation, I was having a baby. So
I understand.
I was literally in the hospital having a baby. So Casey he was stuck giving the presentation. So Casey.
Yeah, the presentation was very well attended. I want to say we had maybe 40 or 50 so people in the audience. I'd say a good amount of them had never considered using composite repairs in those exact types of environments. So it definitely opened up, their thoughts, and there were plenty of good discussions and conversations that occurred afterwards. Really, to me, the primary point of that paper was to show how we are doing a lot of good things with composites in these related, areas, but bringing awareness that composites can be used in the facilities and the locations that you're at really opens up the opportunity and essentially adds another tool for these operators.
Perfect. Thank you. That's all the questions I have. Is there anything you'd like to add that I haven't asked about?
I was trying to think if I had anything. Maybe just in general with composite repairs, that it is something that should be considered by a lot of different companies within the industry. And just knowing that composite companies in general are involved in a lot of codes and standards. So a lot of us are really learning or know more than just what we deal with in the composite industry. Personally, I sit on ASME B314, B318, CSA Z662, and ASME PCC2 as a guest on that specific one. So codes and standards are really being updated on a pretty quick basis to help push the industry or give the industry more alternative technologies. And just in general, that's something that I don't think people necessarily know is always happening.
Adding on to that, if I can real quick, composites, they go through a lot of different testing, and there's a lot of different things that we can do with them. We've done crack testing, bend testing, and a whole bunch of different types of testing. But at the core, composite repairs are a engineered product, and just a word of caution that don't assume all the composites will act alike. They do need to be designed for their own specific materials and defect by defect. So make sure if you want to use a composite repair that you're doing your due diligence to make sure that it's going to meet the requirements that you have for that defect.
Yes, I cannot emphasize that point enough. Coming from being a compliance engineer and dealing with audits every once in a while, you want to make sure that you have that the company you're using has that proper testing and engineering. Otherwise, you're not going to be in compliance with your codes and standards, and it won't necessarily look good on you if the questions come up in an audit. So, which is extremely important. The safety is important, but you want to make sure you can back up that safety.
Yes, it's a great point. Thank you. All right. Well, with that, we'll we'll wrap it up. Again, I'm Kerry Cole, the editor of Materials Performance Magazine, and my guests have been Elise Post and Casey Whalen of CSNRI. And you've been fantastic guests. Thank you so much for taking the time to be with us today.
Thank you.
Yep. Thank you.